Hi, everybody. Thanks so much for having me. My name is Shanelle, and I'm one of the co-founders of Indexical. So Indexical is an AI-powered web crawling and scraping engine. So we allow developers to extract structured data from any set of websites, PDFs, and images with one single API call. So we envision Indexical becoming the de facto platform for working with web data. So any file format, any source, instantly gathered and transformed with the click of a button. So in today's talk, I'll be walking you through why we built Indexical, walk through some of the technical challenges that we've addressed along the way, and then jumping into a short demo for how you might use it to power your unstructured data workflows. So a little bit about myself. I'm one of two co-founders of Indexical. Prior to this, I was a PM at Google, where I led the advertiser experience for a new billion-dollar line of Google Ads. My co-founder Vishnu is also here today, and he previously led a startup that was building in the e-commerce space that heavily leveraged web data. We'll both be available to answer any questions if you want to chat about web scraping, structured data, proxies, etc. And we built Indexical because we've seen firsthand how difficult it is to extract web data reliably at scale. We were both part of YC's Winter 23 batch, and we were originally building an AI dev tool that helped with production issue remediation. As part of that, we ended up crawling and scraping for a lot of developer documentation. So think API docs. And we realized how difficult it is to get this data into a consistent format, crawl through the website, and get it into a format that's intelligible to the LLM. And we realized with the recent wave of AI innovation that this was a problem that other folks would also be focused on. And so we decided to spin out Indexical and have been focused on it ever since. So to give you a little bit of an introduction as to why web data is useful and why folks might invest in web scraping. This is just a brief overview, but at Indexical, we've seen there's three broad use cases. The first is you might want to extract web data to provide input for your LLMs, either for fine-tuning your own model or to augment a knowledge base via RAG. So it's no secret that the reason that OpenAI, Google, Anthropic have been able to create LLMs as powerful as they have today is they've basically crawled and scraped the entire web. But even so, for a lot of companies, you still need to augment that model with specific knowledge for your use case. So imagine you're building in healthcare. Companies often will crawl and scrape for journal articles that come out past the cutoff date, as well as crawling medical resource sites in order to get that model up to the level of accuracy that their users actually need. Similarly, if you're building a customer support agent or a sales agent, companies will often crawl their customers' websites in order to build up a knowledge base so that way the agent can answer questions that's specific to the customer's users. Second broad category is competitive intelligence. This is frequent in e-commerce. So companies will often crawl their competitors' websites to build up a product catalog, ingesting both the products, reviews, as well as pricing. This can be used to build up market research and competitive intelligence, but also power real-time pricing algorithms. So imagine Macy's is running a flash sale on a segment of their product catalog. You at Bloomingdale's probably want to lower your prices to match that, so that way you can provide the best deals for your users. And third broad use case is you simply have a need for aggregated data that's recently updated. So you want to access web data from sources that don't have an API. One example use case here is jobs aggregators. These are companies that will crawl different career sites, aggregating job postings, so that way job seekers can have one centralized place to look for a job. Job postings come out every day. There's tons of sites, meaning that you have to build a ton of scrapers and refresh them in order to get this data scalably. So to our eyes, when you first start thinking about web scraping, this is an example of a careers page where you might want to extract some data. It seems pretty simple, but when you actually get into the nitty-gritty details, there's a lot of technical challenges. So for this example career page, to me, I would start by just like, okay, here are the different job postings. I would click on each job posting, open it up, extract the data. And then it looks pretty simple that there's 59 different pages. So I would just click next 59 times to repeat that workflow. However, when you actually try to build it at scale, there's a variety of wrinkles that may pop up. The first is JavaScript interactions. So if you've ever clicked on a button or searched for something and the content on the page changes, but the URL does not, chances are the website is using JavaScript. So what that means behind the scenes is that the LLM has to identify that there's no link to click, but instead it has to imitate the experience of a human clicking on a button, waiting for the page content to refresh, identifying that the content is done reloading, and then proceeding from there. Second, it's no secret that most websites don't want to be scraped. So it's quite likely that this site, if you're repeating this workflow very quickly from the same IP address, going through all these sites, clicking next very quickly, that it might catch on. So maybe on the 10th next button or the 50th, it may A, throttle the traffic, so it looks like the page has mysteriously failed to load, or B, throw up a CAPTCHA. And third, the website format may change. So this is really common in any modern e-commerce company. Companies like Amazon are constantly running A/B experiments, experimenting with different layouts, different taglines, etc., to see what performs best for their users. With a traditional web scraper, you would use CSS selectors, so actually selecting content based on the CSS classes. With these A/B experiments, those selectors would break, given that the format is changing, making it really hard to extract web data at scale, given the way modern companies run. We chatted with one company where they were trying to scrape a site where on every subsequent page load, the format was changing. And even if you build it for that one site, imagine you have to scrape all of these sites. You can quickly imagine how you're constantly investing in both building scrapers and then maintaining them once they break. We chatted with many folks who are trying to scrape upwards of 1,000 sites. So you can imagine how this very quickly gets complex. So this is where Indexical comes in. We allow developers to construct a domain-agnostic pipeline that describes how to go from a URL to clean structured data that you can actually use. Each step in the pipeline has a natural language goal and a specific action. And then you can run that pipeline across an arbitrary set of URLs. So in this case, example 1, 2, 3, 4, or 5. Behind the scenes, what happens is we will take each of these URLs and each step in the pipeline and map that to the relevant set of actions and selectors in order to be able to accomplish the task. Behind the scenes, how this works is if you were to just feed in the DOM or the raw HTML into OpenAI, you would A, very quickly blow out the context window for large sites, and B, waste a lot of money on tokens. If you think about all the extra stuff that exists in an HTML, like script tags, CSS classes, etc. So what we do behind the scenes is we first start by rendering the page as clean, legible markdown. Then we do some post-processing to add back in any information that's relevant to the LLM. So in this case, it might be what's the title of the site, what are the title of job postings, as well as the links that they refer to, any elements that seem clickable, so any buttons, as well as any buttons that denote pagination. This will become the initial state for the first step of the pipeline. Then we feed that as input to the pipeline. And so each step in the pipeline has a natural language goal and a specific action. Each action is tied to a task-specific agent on Indexical's backend. So we would feed in that cleaned up markdown to the navigation agent and tell the navigation agent, find a page listing the open jobs at the company. That navigation agent will autonomously try to figure out how to accomplish that goal, seamlessly handling backtracking, retries, validation, proxy rotation, etc. It will then return the cleaned up markdown of the careers page of that website. We then pass that cleaned up markdown of the careers page to the next step in the pipeline, in this case, the extraction agent. And so the extraction agent will then try to extract the schema that has been described. So in this case, how to pull the job title. And it will return the cleaned up data, in this case, the job title. So the main goal of Indexical is to repeatedly extract the same set of information from a diverse array of websites. Of course, there are some technical challenges that come up when you try to actually productionize this. The first is, given the non-deterministic nature of LLMs, if you were just to feed in the raw DOM to OpenAI and ask it to pull a set of information, the information extracted may vary slightly from run to run. And second, sometimes it can be unclear to the LLM what information to specifically extract depending on the domain you're working in. So imagine you're working in pharmaceuticals or healthcare, and you want to pull, for a given drug, what is the mechanism of action? So how does it actually scientifically work? An off-the-shelf model might not have the necessary context similar to how a worker working in pharmaceuticals would be able to understand the web page. So how do we imbue the agents with that context so it can reliably accomplish the goal? The first solution in Indexical we have is Locators. The idea of Locators is to be able to repeatedly extract the same set of information while also passing on cost savings and tokens back to you all. So what we do behind the scenes is when we first run Indexical's pipelines on a new URL, we will use the LLM to create Locators, which is basically a mapping between, for a given task and for a given web domain, what are the relevant XPath or CSS selectors to accomplish the goal. We will then try to apply that locator on every subsequent run. Anytime the locator fails, we'll use the LLM to construct new ones. So Indexical is constantly getting better and cheaper for you over time. The other benefit here is it also allows us to have a human-in-the-loop experience. So if you aren't a fan of the way that Indexical is currently extracting data, you can then edit the locators that are used by the Indexical developer console. So you can say, for a given step and for a given domain, here is the CSS selector that you would like us to use going forward. This ensures that you can always have 100% consistency, which is the benefits of manual scrapers, while the self-healing and flexible nature that comes with AI. And the second approach we've taken in Indexicals is we allow you to actually provide examples to basically tune your agent to your specific use case and train it on the task. So going back to the jobs aggregation use case, you can provide examples of here is input that might appear on the web page, and here is what I would like Indexical to output. So in this case, I would like to categorize, like, what is the industry of the company posting the job? So I say, okay, the category is industry. The description is industry of the company posting the job. And here are some examples of what appears on the web page and what I would like Indexical to extract. We then use this with few-shot prompting to basically augment the agent and help train it on that specific task. So I'll now jump into a brief demo. So going back to the jobs aggregation use case, let's say I want to pull the job postings for two sample websites. So loop.com and Scribe. So let's start by walking through the workflow for how I would actually extract this data. For Loop, I would go to the careers page, and then there's a bunch of job postings. And so I would open up each job posting and extract the data from here. For Scribe, it seems like the careers page is not up at the top. But if I scroll down to the bottom, we can see that they do have a careers page. Open it up. Scroll down to the bottom, and the job openings are here. So let's take a look at how we might do this with Indexical. So I would first start by creating a pipeline. So let's name this jobs demo. And so the action that I would like to take is navigate, because I would like to find the careers page. And so then I simply give Indexical the natural language goal. So in this case, find the page listing job openings at the company. And then let's double check that we end up at the right page. So the way I would do that is I would do action, extract, because I would like to pull some information. And then I would describe the schema of the information I'm looking to pull. So in this case, I just want to check that I ended up on the right URL. So I'd pull URL. And Indexical actually provides a variety of special values that denote common data tasks. So in this case, we have one for URL, which basically denotes here is the link to the page that we end up on. So once I save this, I can then run a pipeline on this. So I would simply select jobs demo, and then I would get these two URLs. Run. So while that's running, I can walk through a couple of the different settings that we offer at Indexical. So Indexical is by nature an API-first product. So we have two endpoints: pipelines, where you construct the data extraction workflow, and runs, which is where you actually run that workflow across an arbitrary set of URLs. For each run, you can edit either via the console or via the API, but we allow you to set whether or not you get the response synchronously as a response to the API, or asynchronously, so you can get the results either via a webhook, download via the console, or just use a GET request. We also allow you to edit the concurrency, which is basically the number of links that we will open up at the same time. We have customers that are running over 1 million extractions per month. So you can imagine that you'd want to set the concurrency pretty high in order to ensure that the job finishes up in a timely manner. You can also select whether or not you want JavaScript enabled or not. By default, every website that's loaded with Indexical is loaded in a headless browser with JavaScript enabled. So the experience is similar to what a human worker would see where they're opening up a website on Google Chrome. And then finally, we allow you to select whether or not you would like proxies enabled. So when proxies are enabled, it basically means that to the website, it looks like a bunch of people are opening up different sites around the globe at the same time, as opposed to one bot. So this helps you avoid CAPTCHAs. So let's take a look at the results. Okay, seems like it's still processing. And then you can also generate API keys as well as look through the documentation. So for each pipeline, you can edit and share. And we also support a variety of special actions. So actions are basically the set of different options that we support. So you support like navigation, which we've shown so far. Navigate many, which is basically like if you have like a list of links, you can basically open up each of these list of links. Okay, let's take a look. All right, so we see one result so far. We can take a peek. All right, and you can see here that we've successfully navigated to the careers page. Cool. So now let's proceed with the extraction. So now that we know that we can successfully navigate to the careers page, we now need to navigate to each individual job posting. So we now do action, navigate. But since there's multiple job postings on the site, we would want to do navigate many. This basically denotes opening up a bunch of different links from one page. And then the natural language goal we would give is open up each individual job posting. And then once we've done that, that assumes that in the next step in the pipeline, we've ended up on one individual job posting. So then the next action we would like to do is extract. And now we can describe the schema of the information we're looking to pull. So I want to probably pull the job title, since that's pretty important. And Indexical uses JSON schema. So if you're familiar with OpenAI function calling, it's the exact same thing. So the type is string. And then you give a description to help the AI understand, like, here's what I should actually pull. So the title of the job. And then I want to pull the job description. We also support, and so I just want to pull like the main content of the job description. So another special variable we support is main content. This basically pulls the content of the page as human readable markdown. So if you're doing a lot of crawling and scraping for LLMs where you just want to get the raw content of the page, this would be what you would use. And then finally, I want to pull salary. The type is string, because I want to get all extra information, including if there's benefits. And the description is salary of the role. So once I save that, and then I can also just limit it to 2 so we can get the results a little bit faster. Okay. So now I can clone the run to restart it. And while we're waiting, I can walk you through a couple of the other features that Indexical supports. So the full list of actions we support are listed here in the documentation. We've already covered navigate and navigate many, as well as extract. We also support question answering. So if the information that for the question that you're looking for is not verbatim presented on the page, you can use Indexical to do more, to answer questions that require a little bit more complex reasoning. So example use cases might be summarization or categorization. Extract many is useful if you have a table where you want to extract subsequent rows. So think you want to extract prices on an e-commerce listing page for a variety of products. You can simply describe the schema of one item, i.e. the product, product name, price, image, etc. And then Indexical will then try to extract that schema repeatedly across the same page. We also support form manipulation. So if you want to select filters or search, etc., we can do that and then pull the extractions from the next step, as well as integrate with search queries. So if you don't actually know the URLs for which you would like to scrape, but you know the query that you would put in Google if you were like trying to find this information, you can simply use the search action, include that natural language query, and then Indexical will then crawl and scrape the first N links from that page and then proceed on from there. If you actually want to productize this and get this information into your database, you can then, when you actually start a run, you can also include the webhooks. This basically sets up an automatic action for when the run is completed, either to transmit the data directly or to just notify you that the run is done. So let's take a look at the results. So we have 2 so far. So we can see here we have 2 results so far for Loop, where we're able to get the customer success manager and the job description for both. Fresh. All right, let's wait a little bit longer. So in addition to that, we also support anti-CAPTCHAs. So in addition to simply just rotating proxies, you can also integrate with our anti-CAPTCHA providers, which will basically enable you to access more difficult to reach sites that are more aggressively anti-bot. As well as if you're trying to crawl through an entire page and you know that like you've already scraped a site previously, you can block certain URLs. This allows you to basically like scrape a site repeatedly, but only scrape the new URLs if you're trying to like refresh postings, for example. As well as like match regexes and support validation. All right, the results are complete. So let's take a look. So you can see here, we're able to pull not just the title of the job, but then also the salaries associated with it. So salary, 160K, equity, and benefits. So that's Indexical in a nutshell. Happy to answer any questions. So basically, in this one right now, we didn't have any errors, which is nice. So you can see like the default format for the results is you'll have a JSON where the results are in the results key. But if there's any errors, you can also see it right here. So you can basically do a webhook to transmit and then see like what whether or not the errors array is not empty. Web scraping is something that's been around for decades and has a pretty long legal history. So the Supreme Court has ruled that like web scraping is legal as long as it's on like public data. Our broad position is that we think that like as the web continues to develop, obviously like agents will continue to like crawl and scrape the web. Of course, we'll respect like a robots.txt file, but we do believe that like there are companies that are looking for web data and we want to respect that as well. The broad pattern we've seen with our initial customers is these are companies that are looking to scrape the same set of sites on a recurring basis. And currently they're investing a ton of time and effort into maintaining them because these are sites whose formats are constantly changing. One example industry is jobs aggregators. These are companies that want to crawl and scrape for career postings across a variety of websites. Postings come up every week, so it's really important to maintain on top of it. And then for pricing, we charge on a volume basis. So we have a credit system where basically we charge for proxies, extractions, navigations, etc.
Is it free if you do less than 100?
So right now we're working with design partners, so everyone on the platform is a paying customer, but we are planning to launch a self-serve tier in the next couple of weeks. So at that point, yes, so you can sign up. So Indexical is, by its very nature, a developer-focused product. So I think for right now, as currently designed, we would imagine that this would be primarily used by technical students at universities, potentially for data acquisition needs. So let's say you're working on a school research project and you need to gather a data set in order to basically come up with a response for an essay. The Indexical will be useful for gathering that data since it already exists across the web, and then transforming it into a usable product so you can focus on the more interesting work, which is the analysis. And regarding election years, I think as of right now, I don't see that there's a ton of use cases for like campaigns, for example, accessing voter data, but of course we would be interested and excited to explore that.